Hello, good afternoon. I am very, very happy to be here. I always have quite an adventure getting to this conference. Last year I arrived at 1 o'clock in the morning on the day of my talk, and the short story of this year is that I arrived in Krakow 1 hour ago, I landed 1 hour ago, and we just made a mad dash from the airport. But all credit to my Uber driver for getting me here on time. So, if you want a long story, just come and grab me for a beer or a coffee later. So, I'm going to talk about service boundaries today. I work for a company called Particular Software. Has anyone heard of Particular Software? We're the makers of End Service Bus. Anyone heard of that? So, see most of the hands going up. That's great to see. At Particular Software, our mission as a company is to make organizations better at delivering, building, and maintaining complex systems. Now, that means talking to a lot of our customers and coming to conferences like this and talking to people like you about your systems and the complex problems you have. Now, one of the really common themes, or one of the things we find ourselves saying quite early in those conversations is, if the service boundaries were a little bit different, if you'd sliced up this system in a slightly different way, this problem we're talking about right now, it might just not exist. We might not be even having to have this conversation. And this is such a common theme that I think it's really important to talk about how to find the right service boundaries and how we can actually avoid a lot of problems in the first place and make our systems more evolvable at the same time. Now, I may take some of the common practices and some of the things that you may have learned as developers and that we've all learned, and I may kind of really turn them upside down. So that may raise a lot of questions. I don't know how much time we're going to have for a Q&A during the session, but I am going to be around afterwards, so please do challenge me on any of this stuff if you think it's a bit controversial or you just don't think it could work. So I am going to be introducing some kind of weird things into the equation. Now, let's take a look at a system, and this is really kind of any system. It doesn't really matter what it is, but we do tend to write our programs in this kind of way. So we do break things up into smaller pieces. So there could be classes. If you're a C# developer, there could be functions. If you're an F# developer, it doesn't really matter. But we don't tend to just write program main and just stick all our code in there, right? Or I hope we don't. I used to write code like that back in the 80s. But these days, we do kind of break things up into smaller things. Now, you can kind of see, this actually looks quite nice, right? So you can kind of see that we could kind of draw a boundary around something up there. You know, that's got some kind of responsibility. And there's something down here which we could draw a boundary around. But at this point, we haven't actually defined any architectural constraints. We're not saying that this is a kind of service off on its own, or this is a service. These are just bunches of classes which happen to look quite nice the way the code is structured right now. Now, the thing is, at some point, the business might come to you with a new idea, some crazy new business idea, and you might say, well, that's something we never thought of. But I think the information we need we need something up here. We need to make a change up here somewhere, but the information we need is down here. Now, you think to yourself, well, how are we going to get this data from one place to another? Now, we could kind of swap things around. We could change things around, try and change the structure, or we could just make the call. Now, remember, we've got no other architectural constraint here. All we've got is a bunch of classes. And when you're looking at the code, you see your classes, right? And the classes are nice encapsulations, they've got nice interfaces, and this is what OO is for, right? It's about encapsulating code and data inside some kind of object. So you make the call, you roll out into production, and everything seems fine. Now, sooner or later, the business come along with a new requirement, and you say, well, we kind of need to do the same kind of thing again. We need to change something up here, but we really need something from some data down here. So you think to yourself, right, the last time we made this kind of change, it worked out fine, right? We're adhering to our object-oriented encapsulation. We're not diving in and sort of calling private methods or anything like that. So it makes sense to make that call from class to class, and you make the call. And you roll that into production, everything's going fine, but I guess you can kind of see where this might start to go. Sooner or later, you might get another requirement. You might make a call from one class to another class again. And it could be the case of, over time, and this could be a large period of time, you may look back 6 months later and see something like this. And no one sets out to do this, right? But I see a few smiles, and I can see a few hints of recognition here. I think some of you have seen this kind of thing happen before. Now, the problem is that you can't really make changes to this code anymore with a great deal of confidence, because you end up having to kind of go on this code safari, where you try and make a change in some place, and then all of a sudden you find out that that class has got its fingers in many other classes. And then you find that many other classes are calling that class. And then you break something, and a test breaks. So, I don't know, you might delete the test, or you might just change things around again and try and get things working somehow. And then in the end, you get it working, but you're in this kind of edit and pray mode of operation. You kind of make edits and pray they're going to work. And when you make a change, you might say to your colleague, well, did you use this diagram? Like, did you use the diagram to help you make that change? And then they say, what, that thing? That thing is absolutely useless. It's a plate of spaghetti. So you're not really even using this thing anymore. And that means the lines in the diagram are not really useful anymore, because they are just a plate of spaghetti. So you might as well take them away and just have a bunch of boxes. Now, what we've got here is a bunch of classes. And the thing is, you can't really use this diagram for much either. Because you might look at one class and say, oh, well, that's nicely encapsulated. I can see what this class does. I can see what its interface is. But you're in the same kind of situation. You make a change, you break something somewhere else because you don't know what's calling into that class. And this diagram doesn't really tell you much either, because the only way to find out how to do things is just to get into the code. So you may as well take away the boxes and have one big box. And this is what sometimes is known as a big ball of mud. Has anyone seen this kind of architectural pattern before? I see most of you picking up your hands. I think I've actually worked with systems like this throughout most of my career, unfortunately. They tend to evolve slowly, gradually. No one tends to do this, but the big ball of mud happens just all too often. Now, we know we can do better. So we read about service-oriented architecture or microservices, and we split things up into services. And then what we try and do is to have very well-defined communication between these services. I've deliberately drawn these lines very small because that's intended to represent a kind of loose coupling where we don't have much data going between the services. Now, that's all fine, but sooner or later, the business will come along with a new requirement. And you'll say, well, I think we can do this, but what we really need is some data in the service on the right from the service on the left. And it might be something really innocuous. It might just be a price, so the price of a product. What harm can that do? So you share this price, this single number across the services, and you roll it out, and everything's fine. Sooner or later, they come along with another requirement, and you say, well, you know what, we can do this too, and we really need some data from the service on the bottom left in the service on the top left. And you make the same kind of change again, and you can see where this is going, right? Over time, again, it might be a long period of time, you might end up with something like this. And again, no one sets out to do this. And at that point, we've seen that the arrows are meaningless, the boxes start to become meaningless, and you end up coalescing back into this kind of big ball of mud scenario, which no one wants. This time, it's slightly different, because you may have rolled out these 4 services onto 4 machines. So your deployment model is more complicated. You may have to roll out 2, 3, or even 4 services at a time. They need to talk to each other across the network. Even if that's local host, it's still quite inefficient compared with in-memory class to class. So we've ended up in a worse situation than we started with. And that's a real shame. And that's a real shame because service-oriented architecture or microservices was supposed to help us. It's actually ended up damaging us and left us in a worse position. So how can we avoid this? How can we avoid getting back into this big ball of mud? Let's have a look at a workflow. Amazon is an example of a highly service-oriented company. There is no Amazon.exe, 1 terabyte file that they roll out. It is a bunch of services that collaborate with each other. In fact, it's probably one of the most service-oriented companies in the world. By direct instruction from the CEO, they are fully service-oriented. And when you buy something on Amazon, you enter into a workflow. So you go through this workflow of entering your shipping details, entering your credit card details, other shipping options, and at the end, you place your order. So at the end of the workflow, you've entered all the data, you send it off to Amazon, and they go off and fulfill your order, as long as you can pay for it. Now, if we look at what happens in the back end, we might have, behind this, 3 services. So we've got sales, finance, and shipping. We send a command into sales to say, place the order. Sales then raises an event to say the order's been placed. And the finance and shipping services subscribe to that order placed event. And finance will actually bill the order, and shipping will, once the order's been placed and the order's been billed, shipping will send it out the door, and it might raise an order shipped event for something else to talk to. Now, what should those events contain? Should the order placed event contain all the info that finance needs in order to bill the customer? Should it contain all the info that shipping needs in order to ship the order? Now, that would work. Yeah, that would work. But what's the problem with that? It's coupling. The problem there is we're sharing a lot of data between the services. Imagine if we want to introduce something like Bitcoin payment. Now, we would not only have to give finance all the knowledge of how to charge in Bitcoin, we'd have to tell sales how to propagate the information, what information to collect and to put on the event to give that to finance so that it can either charge a credit card or it can charge Bitcoin. What if we decided to start shipping ebooks? We don't want to give sales all the info it needs in order to pass along the information for shipping an ebook as well as shipping a physical book. So the problem then is the responsibility of shipping is no longer encapsulated in shipping. It's smeared across shipping and sales. What I just described are fat events, events with a lot of data on them. We want to slim those down. We want to slim those down to thin events. What if each event only contained an ID? Just an ID. So order placed, all that has is order 123. And then finance says, order 123, I know how to ship that. I'm going to ship it to this address. Sorry, finance says, how am I going to charge for the order? I'm going to charge the customer via credit card. Shipping says, I know how to ship order 123. I'm going to ship it to an address or send an email. And likewise, order bill just says, order's been billed 123. And shipping already knows how to send the product for order 123. Now that's nice because there's no more data coupling. It's just IDs going across the wire between services. But we have a problem, right? We have a kind of chicken and egg problem because if we're saying to sales, place the order, and sales says, okay, the order's still that product is still for sale. We've got it in stock. Right, I'm going to place the order. So we write a row into a database, it gets an ID. How should finance already know about that order if we're only creating it at that point? How can we say order placed 123, and how can finance even know what that means? So we need to know the ID before the order's being created, but we don't have the ID until the order's being created, right? Now, that's working on the assumption that we create the ID when we click place your order, right? Now that is the end of the workflow. What if we turn that upside down and we create the ID at the beginning of the workflow? Now the beginning of the workflow is this. It's proceed to checkout. We can create the ID when we say proceed to checkout. What that means is when we go into our workflow, by the time we get to this screen, we've already got an ID. So we send a message to the shipping service to say, you're going to ship this order to this address. By the time we get to finance, we've got an ID. We say to the finance service, for order 123, you're going to charge this credit card. And so forth and so forth and so forth. And when you click place your order, all sales has to do is worry about its responsibilities. It just has to worry about, is the product still for sale? Have we got it in stock? If not, can we order more? Yes, we can. And it raises an event to say, order 123 has been placed. Finance has already been told how to charge for it. Shipping's already been told where to ship it. Now we can add Bitcoin in a way that we can encapsulate that in the finance service, because sales doesn't have to know anything more about it. And the thing that allowed that, the one weird trick that allowed that, is setting the ID up front instead of at the end. Now, you might think, well, what happens if you don't complete the order? Right? So I say, okay, ship it to this address, charge this credit card, and then, I don't know, maybe your spouse walks through the door and reminds you that you've bought too much this month and you close the browser window. There's going to be a whole load of redundant data, right? There's going to be a whole load of redundant data in shipping, a load of addresses we're never going to ship to, a load of credit card details in finance we're never going to charge. And you might think, well, something should clean that stuff up, right? That's kind of like random stuff we don't want. We don't want to be keeping that forever. But ask yourself, is it really redundant? Do businesses want to know about orders that haven't been completed? Do they want to run analytics to see what kind of products are people backing out of buying at certain times and not others? This can be really rich analytical data for businesses. You know, some businesses would kill for this kind of thing. They hand things over to their designers and say, look, everyone's trying to buy this certain thing, and a high percentage of them are backing out, but they're not backing out of this thing over here. What's the difference? I don't know, let's try some A/B testing. So it can be really, really valuable data. And you don't even necessarily need to hold it in a database. So credit card details, you have to be a bit careful what you do with those. So they could just be session state. So when the browser window closes, it just naturally disappears. So what is it that led us back to this? Why did we get back to a big ball of mud when we introduced services? It was this thing here, right? This is the sharing of data. We took a price and we shared it from one service to another, or it could be a quantity of an item, something really innocuous. It's the sharing of data that leads us back to the big ball of mud. So let's try and define a little bit more about what a service actually is. Now, first of all, what a service is not. Something that is just kind of functionality, like calculation or validation. That's not a service. That is just a function. Something that is just kind of CRUD, right? Just create, read, update, delete on records. It's not a service. It's just a database, right? And putting HTTP in front of it does not make it a service, right? You don't just magically sprinkle HTTP on a database and say, hey, we've got services. It's just a database. You haven't changed its logical concern. All you've changed is its physical entry point. A service, rather, is a technical authority for a specific business capability. And really importantly, everything belongs in some service. So all the code we write is for some kind of business capability, right? We don't just write code for fun. Unless maybe your project's failing and you're just going and learning a new language and doing some kind of CV, resume-driven development. But generally, the code we write is a business capability. It's for a business capability. So it makes sense that nothing is left over, right? We don't just have service A, service B, and service C, and then other stuff, because that avoids us asking the really difficult questions. It's when you can't find somewhere to put something into some service, that's when the really interesting and detailed analysis starts. It's a bit like, if you think about OO, right, object-oriented programming, that was never about polymorphism and inheritance. It was always about encapsulation. And objects are great, but the thing is, you can't really do anything non-trivial in an object-oriented program without sharing some data between the objects. So components are somewhat better. You can think about maybe, assemblies, packages. They're better, but you still end up sharing some kind of data between those packages. The key difference is that those are physical boundaries. Okay, an object or a package, that's something aligned along a physical boundary. It's an actual binary object. Services are encapsulation at a logical level. They're encapsulation at the logical level of a business capability. If you like, you do away with the shackles of the physical and you only think about the logical when you're thinking about a service boundary. So it's really, if you like, the ultimate expression of encapsulation. And ultimately, that's what all these things are designed to do. Classes, components, packages, and ultimately services. It's all about encapsulation. Now, if we look at systems and services have a special relationship. Here we've got a mobile app, a .NET backend, a Java portal, and we do not define our services around these boundaries because services are something different. Services cut across these things. Systems are physical runtime concerns based around technical boundaries. Services are logical design time concerns based around business boundaries. So what this means is that one service can have components running in many systems, and one system can have components from many services. It's a many-to-many relationship. Now, if there's one thing I'd like you to take away from this talk, it's probably this. It's trying not to conflate the physical with the logical. A service is not a physical thing. Sometimes we think of a service as a process, a Windows service, if you like. The word service is very overloaded. But these are two different things with two different purposes. The physical and the logical, two different things. So how do we actually go and find these boundaries then? So let's take a typical domain. This is something which you might draw something like this on a whiteboard. You might say, oh, look, we've got a customer. Customer has a last name, has a first name, has a status. Products, well, they have a name, a description, and a price. And you kind of draw these boxes on the whiteboard, and then you might write classes to represent them. Anyone here read Eric Evans' DDD, Domain Driven Design book? Well, I think it's probably at least half of you. So this is something that he talks about a lot, about entities, right? These are what he classes entities. Now, the thing is, it becomes more interesting when we start to look at use cases rather than data. If we take the customer and we say, right, we've got a first name, a last name, and a status, we can ask questions about that data. We can ask the business. See, the business often don't know what they want, but they almost always know what they don't want. So you can use a technique which I call anti-requirements to ask questions like, if the customer's first name begins with an S, does that affect their status? And the business will look at you and say, they'll give you a really strange look, and they'll say, look, you have no idea, do you? That is so ridiculous that we would never do that, and no one in this industry sector would ever do something so crazy. Now, when you hear that, you've actually struck gold, because what have they just told you? They've given you a stable business rule. They've just told you that there is no relationship between the customer's first name and last name and their status. So what are they doing in the same place? Why don't we put them in two different places? Let's put the customer's name in this pile of stuff over here, and let's put the customer status in another pile and so on over here. Now, we can ask questions about the customer status, which looks a bit lonely there. What is the customer status? What is it used for? And the business will say, oh, well, we'll use that to work out the price. So if a customer's a gold customer or a preferred customer, we'll give them a bit of a discount. So you think, okay, right, so price has got something to do with customer status. I don't know what yet. I don't know what the relationship is yet, but I'm going to put them in the same pile because they're somehow related. And at this stage of modeling, this is all we're trying to do. We're trying to get our data and we're trying to put things into related piles of stuff. Eventually, this might end up driving our service boundary design. And then we've got things like the product's name and description. They kind of complement each other. So if a product is a Dulux something, you want the description to tell you why it's a Dulux something and why you should pay more for it. So we're going to put them in a pile over here. Now, consider the difference between the bottom row and the top row. They're quite different, right? And the problem is the top row is more of an entity-first approach. We're saying things like customer has a first name and has a last name. Look out for that phrase, has a. If you find yourself saying X has a Y, it's a strong sign you're going down an entity-first approach. And modeling is not about that. Modeling is not about nouns. It's not about the physical, tangible things. This is tough because our brains are kind of hardwired for this. When we start talking to the business, they start talking about customers and products, so immediately we latch onto that. We latch onto that and draw customer entities and product entities and order entities. But that can drive us down. That can drive us to the wrong model because that means we'll end up sharing a lot of data between these different things. So it's not about entities; it's about behaviors and scenarios. Right? I'll even go so far as to say entities, bad. behaviors and scenarios, good. And Eric Evans, when he talks about his DDD book, he actually says that in the end, he said he wished he left out all that stuff about entities in the book. So beware of the entity-first approach. Look for models, look for scenarios and behaviors, look for the detail. The devil really is in the detail. Also, don't name these things too early. This is one of the biggest pitfalls I've fallen into before. Give these things meaningless names. The problem is, if you end up calling something billing, you might end up in a conversation where you're trying to fit something into your services, and you'll say, well, that can't possibly belong in there because that's billing. Or you might say, well, that can't possibly belong in there because that's inventory. Or, oh, I know where that belongs, that's clearly customers. The problem is that if you name too early, it'll stop you from putting data in the right place, and it'll prevent you from finding the right place to put data. So stick with meaningless names, for a while at least. I've actually worked in a team before where we decided to always just have meaningless names. We use kaiju monsters. So the most famous one is Godzilla, and then there's Mothra and Batra and Udaku and all these weird and wonderful things. So it's a good way to avoid getting into that trap. Let's take another example. Let's look at a hotel. So a hotel is, again, this is something we're all familiar with, right? And it's also tempting to say, well, we don't really need a domain expert here because we know about hotels. We've all stayed in hotels. So we start drawing on the whiteboard and we write, okay, guests, rooms, availability, and that kind of thing. But again, we need to resist that temptation, right? And we need to think about looking at the use cases, the data, the scenarios. And you probably want a domain expert in the room with you. Even if you think you know about hotels, you know about hotels from the context of being a guest, not from running the business. So even in obvious domains, it usually pays off to have a domain expert with you. So if we look at a typical use case, this is searching for a room, right? So I think at this time I was searching for a room in Oslo. So this is in Norwegian krona up here. But if we start looking at the data that makes up this screen, we can start to pull out the actual detail into our separate piles. So let's see how that looks. First of all, we need some kind of room type. So you don't book room 123. You book a deluxe room or a suite or whatever. So you book a type of room when you're booking a hotel room. So first of all, I'm going to write down room type. Now, in order to work out whether a particular room type is available on a particular set of dates, we need to know the from and to date. We then need to know what capacity of that room type have we got. And then the last thing we need to know is what bookings have we got for that room type. So we need some kind of booking idea in as well. Now, this is not a database, this is not a class diagram or anything like that, but you can see that somehow, through this combination of things, we can say, right, from this date to this date, we've got this many rooms of this type available. So that's our first pile. The next thing, of course, is price. So we're going to put price somewhere separate because price doesn't really depend on availability. Now, you might be thinking about airlines where the price goes up as you get closer to the flight date, but hotels don't really work like that. They tend rather just to sell big blocks of rooms to something like Booking.com. So the price tends to stay fairly stable. Now, one thing that does influence the price is the date. So the actual date itself. So we might charge more at weekends, we might charge more during the week, we might charge more at Christmas, etc., etc. So the price is influenced by the actual date of the calendar year. And then last of all, we've got on that screen, we've got the name and the description of the room and a picture of the room, and those things kind of complement each other. If you're booking a suite, you want to see that it's a picture of a suite, and you want to be told why a suite is so nice and why you should book it instead of a single room. Now, the next part of the workflow is selecting the room. Now, there's one very important thing here. I know the text here is very small, but that says 3,937 krona for the entire stay. You want the same number on this screen because that price might change. We might have a new pricing policy coming into effect, right? So we might actually change the prices of our rooms between the user looking at that screen and looking at that screen. Now, you want the same price to be shown in both because you can actually get into a lot of trouble for not doing that. That's actually false advertising. You can actually get in a lot of trouble if you show a different price when they select the room. So somehow, we need to associate this price with what the user is doing here. So this session, if you like. Why don't we actually create the booking ID right at the front? Why don't we actually create the booking ID here when we search for the room? Just as we saw with creating the ID of the order at the front of the workflow on Amazon. We create the booking ID here, we go to this screen, we're still on the same booking ID, so we see the same price. Now, how does that look like in our model? Well, we've got two options really. Either we take the price and we copy it over here, or we take the booking ID and copy it over here. Now, price is interesting because you might think, oh, well, price is just a number, right? It's just some arbitrary number. Let's just copy that across. But the thing is, price isn't actually that simple when you look into the detail. The price can change, but depending on whether you've got standard rates, prepay and save, deals and packages. Price is actually quite complicated when you look at the detail. So instead of copying this less stable business abstraction of price, which can change over time, as the business get new ideas, let's instead copy the far more stable abstraction of the booking ID over to the right. Because ultimately, you're not going to get many requests to change the booking IDs from strings to GUIDs or from GUIDs to integers from the business. That's meaningless from a business point of view. So now the last thing to do in this workflow is to actually fill in your details. And again, you can invoke things like anti-requirements to find out, well, does the user's name and their status affect the price or the availability? The business will say, well, stop asking me these silly questions. They give you the stable business abstraction or the stable business rule that guest info is something separate. It doesn't affect these things. So we put the guest info and the booking ID into another pile. Now, this is a good kind of tip, is just to, if you can put stuff into a separate pile to start with, put it in a separate pile. You may find later that this yellow service boundary down here is really not doing anything apart from CRUD. It's just kind of creating, reading, updating, deleting guest info, which is not very interesting. So you may decide to fold this back into the green service or perhaps the white service. But start off with it separate and then see where it goes. Again, don't name these things too early. And this is ultimately, I can't really give you a flow chart of things to ask. I can't say, well, if this, then that, if this, then that, and then out pops your domain model. This is a set of tools to ask. Anti-requirements, putting things in piles, looking at scenarios. This is a set of tools at your disposal to try and find the better business boundaries. So insurance, let's have a look at another example. Does anyone here work in insurance? None of you. Wow. Okay. Must be obviously not a big thing in Krakow. Insurance is an interesting domain, though, and the thing about insurance is that it's often broken into a kind of front office and a back office scenario. The front office in insurance is all about selling fear. Ultimately, they want to make you afraid enough that you will buy insurance against bad things happening. And I actually spoke to some people in Russia about this once, and the word in Russian for insurance actually has fear in it. Is that the same in Polish? Well, anyway, so it does show you that it's not a bad way to describe what the front office does in insurance. And the back office is all about working out how little we can pay when a claim is made in order to satisfy that claim. Right? Sounds a bit cutthroat, but that's basically the DNA of a successful insurance company. Maximum in, minimum out, just like any business. So you might go into an insurance company and you might see a model like this. So a policy service, which is all about selling policies, kind of model around the front office, and a kind of claims service, which is all about the back office, about working out how little we can pay when claims are made. The thing is, I don't know anything about insurance, really. I buy insurance, but I don't know anything about running an insurance company. But I can tell you straight away that that is probably wrong. Why? If we look at a typical use case, think about making a claim. What's the first thing that the claims service is going to do? It's going to make some kind of request to the policy service to find out, well, what are the details of the policy? How can we get away with not paying this claim or paying as little as possible, right? A whole load of request response between two services. And then we're back into that coupling, we're back into that data sharing problem. Now, you might have a flash of insight at some point, and you might realize that, you know what, car insurance doesn't have anything to do with house insurance. And house insurance doesn't really have anything to do with travel insurance. So you draw some other boundaries based along those lines, and then you say to the business, and let's say you might be a consultant. You might be a consultant coming in to do this. And in fact, a colleague of mine went in as a consultant, and he was given these exact boundaries, the front office and the back office boundaries to analyze. And you go to the business and you say, well, guess what? I've had an earth-shattering insight. I've discovered that house insurance has nothing to do with car insurance. And car insurance is very different from travel insurance. And the business say to you, how much have I just paid you to come in and tell me something which I've known my entire career? You know, that's obvious. If the business ever tell you that's obvious, that's a very good sign. It's a very good sign you've got things right. Now, you might ask yourself, well, why didn't we just ask them in the first place, right? Why don't we just say to them, well, how's your business organized? Oh, we've got house insurance, car insurance, travel insurance. Great. There are service boundaries, off we go. You might get lucky, but the problem is that this row on the top, front office and back office, that's also obvious. So you never know what dimension they're going to cut the business across when you say to them, how's your business organized? It won't work to come in at this high level. If you come in at this high level, you'll be ignoring the use cases and the scenarios. It's not a high-level top-down exercise. And that, again, I think it's quite difficult to break out of that way of thinking because we're trained to look for the high-level components. We draw them on a whiteboard, and we delve into the detail later. It's actually the other way around. So the high level, the detail doesn't emerge from the high level. The high level emerges from the detail. It's looking at the scenarios, the use cases, the data. The devil is in the data. That's what will reveal the service boundaries to you. And it's only when we looked at the use cases we discovered that the original design wasn't correct. And organizations in general are a bit of a trap in this regard. The problem is that it will be nice to go into an organization and say, oh, well, we've got a billing department, a finance department, a shipping department, great. Those are our service boundaries, let's go. The problem is, I think at one time that might have worked. If you think back to before everything was automated with the computers, where did data live? Data lived in filing cabinets. And the cost of accessing data was actually very expensive. So a piece of data you need might be in a filing cabinet on the other side of the building somewhere. So actually going in, getting and looking at data is quite expensive. That forced people to be organized around their data. You tended to be organized, you tended to have the filing cabinets that you needed for your job near your desk. So organizations were almost forced to be service-oriented. The problem is we came along with our fancy databases and our fancy workstations. We put one on everyone's desk, and all of a sudden anyone can access anything. You know, as long as the right security flags are set, but that's often a case of just knowing the right person. So the problem is the modern department has gone from something being very service-oriented to being a kind of fiefdom, a kind of mini-kingdom, if you like. It doesn't necessarily model anything more meaningful than a manager's skill at empire building and skill at getting more people under them in the org chart. Now, I've been in organizations before where my organizational unit has changed 6, 7, or 8 times in a year. That's not a stable business abstraction. Right? I don't want to be having to change my business boundaries every 6, 7, or 8 times a year. So beware of the organizational boundary, which is a real shame because it would be a nice shortcut, but it can very often lead us down the wrong path. Now, where do microservices fit into all of this? I'm sure most of you have heard of microservices, maybe doing microservices. Now, microservices have a lot of good stuff that's come out of microservices. So I think there's a lot of good practices which have come out of this. I do have one concern, though. Microservices are another tool in our war against the big wall of mud. Right? This is what we're trying to avoid. So we read about microservices and we say, okay, well, let's break this up into 5 microservices. Okay, that's looking a little bit better. But then you read some literature which says, well, 5 microservices really isn't enough. You should have at least 10. So you split things up a bit more, and I think we've got 13 microservices now. And you think, okay, well, great, we must be doing microservices now. And then you read some more literature, and it says, well, you know what? You shouldn't have a microservice which would take you more than a week to rewrite. Or even worse, it should only be 200 or 300 lines long. So I think, okay, well, clearly we've got too many we've got microservices too big. We need to break them down a bit more. So you break them down a bit more, and does this diagram look familiar? Then you read some more literature, and you read that, well, no, actually everything's got to be running on Docker, so you do all this other stuff. And you think, right, well, we must be doing microservices now. And then the business come along, and they come along with a requirement. And you discover that what you actually need is some data up here from a microservice down here. We haven't drawn any architectural constraint which says that we can't make this call. These are microservices. These are our service boundaries. If they're doing their job, there's no reason we can't make that call. So we make that call, we roll out into production, and everything's fine. Then the business come along with another requirement. And you discover that you actually need to do the same kind of thing again down here, and you know where this is going. Right? We've seen this before. Over time, and again, no one sets out to do this. This can be a large amount of time. You may end up with something like this. Right? So we're back to where we were before, and we've seen that the lines don't mean anything, we may as well take them away. The boxes don't really mean anything as well. Again, we may as well just draw a big box, and we're back to the big ball of mud scenario. Only this time, it's a big ball of mud running on 100 Docker containers. Your deployment model is a little bit more complicated. They're all talking to each other over some form of network. So again, we've ended up in a much worse situation than we started with. And again, this is a real shame, because microservices were supposed to help. But we've ended up in a worse situation. They've actually damaged us rather than helping. We've ended up with a microservices edition. Right? It's a big ball of mud, microservices edition, and we want to try and avoid this. So we want something which looks more like this. We want 4 services, or a smaller number of services, with very small lines of communication. We want loose coupling between these services. Ideally, only IDs going across the wire. Now, if we look within these services, we might see smaller components, right? We might see these smaller kind of autonomous components. And as we've seen, we take bits of these and we put them into a system. Now, think about it like, I often think about it like Lego. So when you build with Lego, you start with that green board, and you have different piles of bricks. If those piles of bricks are your services, building a system is taking the right bricks from each service and building a house on the green board, and that's your system. And that's what we do here. We take components from different services and we build them into a system which is a deployable unit. Okay, so remember, this is the separation of the physical concern from the logical concern. Now, you may think, well, within one of these service boundaries, could I build a small ball of mud? I mean, this one down here on the bottom right, it's starting to look a bit complicated, right? Now, I'm not going to say that it's impossible. I'm not going to say that, no, you cannot build a big ball of mud here. Yes, it's possible. You can build a mess with any kind of architectural approach. But it's less likely. I will say it's less likely, because the thing is, we've already split this system along business concerns, right? We've already split this along logical concerns. So the responsibility of one of these services is much more crisply defined. So yes, you could build a big ball of mud within one of those things, but I think it's much less likely, because what we actually do within these things is we split things up for a different reason. We don't split these up to try and help our understanding of the system. We split them up for other reasons. Take a look at this service down here. Now, this might have the responsibility of something to do with bank accounts. And 2 of the things we might want this service to do is creating bank accounts and locking accounts for fraud. So if we suspect fraud on some kind of bank account, we see some unusual activity, we want to lock that bank account straight away, because ultimately we'll be responsible for any fraudulent money that goes out. Now, if I send 1,000 messages to that service to say, create bank account statements, and then I send one lock account for fraud command to it, we don't want the command to lock the bank account to be backed up behind 1,000 messages to create bank statements. Right? We want that to be done straight away. So we split that up into two responsibilities. We have statements over here, and we have fraud over here. We give each of these their own queue, and the statements component, we might put that on, I don't know, 2 machines, just for failover. The fraud, we might put that on 10 machines, all looking at the same queue, all competing for messages. Or we might elastically scale it or something. So we're satisfying 2 very different levels of SLA here. We're saying, well, statements, we can create those in half an hour, it doesn't really matter, or even tomorrow. Fraud, that's got to be done straight away. So we split these up for very different reasons, and this is really taking advantage of the microservices approach. And you can take advantage of a lot of things you read in the literature about microservices when splitting up within a service boundary into these smaller components. I don't really like the word microservice for 2 reasons. First of all, micro. It implies that size is something important within this kind of design, and I really don't think it is. And service, so it's another thing that's competing for this overloaded term service. And I think the problem with that is that it distracts us from thinking about the logical services. It draws us into conflating the physical with the logical. So that rather than these 4 big boxes, we can take those away and we can say, well, all the smaller boxes within those are actually our service boundaries, but they're not. So that's the one big thing I'd like you to be aware of when thinking about microservices and their relationship to service-oriented architecture is remember the separation of physical and logical. Don't let your microservices distract you from thinking about the logical service boundaries. Okay, so we're coming towards the end now. If you want to get into some of this stuff in a lot more detail, I've actually put together a video package at this URL. This is actually Udi Dehaan, who's the CEO of particular software. They are an extract from a larger course that he runs for 5 days, which you can look at online or in person a few times a year. So if you want to get into some more, this is a taster of this stuff, but there's a lot more detail behind it. So go there, have a look at the videos, and continue with and hopefully you can continue with some of the stuff I've been talking about today. Now, I'll just finish off by saying that service-oriented architecture and service boundaries, like anything that you learn about, are not a silver bullet. Right? They're not a golden hammer. They're not the thing to be used in every kind of situation, and they will make your life wonderful. I think there's one very strong example of that. Does anyone here work in a startup or a startup-ish kind of scenario? I see just a few hands going up. So if you're getting excited about this stuff, I've got a little bit of bad news for you. Service boundaries are based around stable business abstractions. Startups don't know what the businesses are. So it took Facebook quite a long time to realize that it's actually a media company. Startups are really kind of, what you do in a startup is you kind of throw your toys on the floor, make a mess, and you think you've got something good, you think you can make some money somehow, but you need to kind of play around and find out what that actually is. Now, the thing is, you may be thinking, well, but this is a real shame. This is a startup, it's kind of greenfield. We can go in and do things properly. But the problem is, no matter whether you follow a kind of service-oriented architecture or you just kind of throw things together and try things out, once you find out what your business is, you're probably just going to have to rewrite the whole thing anyway. So be careful about over-investing in a more expensive technique like service-oriented architecture rather than just trying stuff out and seeing what sticks. So don't go into this too early in a startup, would be my recommendation. So I hope that's been enjoyable. I hope that's something useful, and I hope we can continue to work on our complex systems together, and hopefully finding the right service boundaries will help us do that in a much better way, avoiding some of the problems we see and making your systems far more evolvable as we go along to the future. As I say, I'll be around for the rest of the time. I haven't had time to do a Q&A, but I am going to be around, so do grab me anytime, and we can keep talking about this a bit more. Thank you very much.